record kar. So first question, February, March 2022. First question. Draw lines to represent the gravitational field around P. And P is a point mass. Okay. So that's pretty simple. Arrows inwards, please. Like this. Then moon is in a circular orbit around the planet. Explain why the path of moon is circular. This is because the gravitational force provides the centripetal force. Okay. Then goes next one. R cube and 1 upon omega square. Okay. Where show that the mass of the planet is given by expression where G is this. Okay. We could do that. Gradient, na? Acha. So the gradient of this is change in y, which is r cube, over change in this. Okay. So the gradient basically represents omega square r cube. Omega square is basically, there's no omega for some reason here, right? There's no r even, which is good, fine. Centripetal force is mr omega square. And centripetal force is gmm over r square. So gmm, m and m will cancel out. So gm equals to r cube omega square. So iska matlab ho gaya gm ke barabar. Just replace the whole thing. So then m will be equal to gradient divided by g. Proved. Pretty simple. Now using figure 1.2 an expression, show that the mass of the planet is this. Acha. Now because it starts from 0, we can take any value, really. So let's just take this one. This is 6 times 10 raised to the power 7. And this is 4.1, है ना? 4.1 times 10 raised to 23. Okay. So जो gradient है, gradient will be 6 times 10 raised to 27. Sorry, 7. And okay, ये तो x-axis में आ गया. 4.1 times 10 raised to 23 minus 0. 6 times 10 raised to 7 minus 0. Wait a second.
So it's 6.83 times 10 power 15.
6.83 times 10 power 15 is the gradient. And then we just need to divide this by 6.67 minus 7. So this should come out as
RS.
1.0 times 10 raised to 26 kg. Proved. Give me a something. Okay. Determine the speed of moon in orbit around the planet in actual radius of this. Determine the speed of the moon in orbit planet with the actual radius of this. So I don't think so. Okay, let me say So we need speed. For speed, what we can do is we have g, we have the mass, we have the radius. Okay, so gmm over r square is equal to mv square over r. You can sum. You can sum. Gm over r equals to v square. So v will be under root of gm upon r. So let's use it. 6.67 times 10 raised to minus 11. Mass is 1.0 times 10 raised to 26. And the radius is 1.2 times 10 raised to 8 root. What was the answer?
7,500.
7,500 is the answer. Okay, very good. Now let's go to the next one. Okay, so in this question it says fixed mass particle gas. The gas undergoes a cycle X, Y, Z, X. X, Y, Z, X. Okay. Table shows this. Okay. State the internal energy for one complete zero. The reason behind this is that it reaches the same point, right? Now it says calculate the amount of gas. Okay. So we have temperature, we have volume, we have pressure for one of it. So we can use this. PV equals to nRT. 1.5, 4.2, and 8.31, 540. What was the answer?
0.14.
0.14.
Very good. Then complete the space below. Achha, complete the tables, use space below. Well, क्या बात है? This is like a very, very different question from the very first time it came. चलो कोई बात नहीं, अभी हम कर लेते हैं. So we have this, and we have the moles. So I guess we can use the moles by ourselves. I think we can do that. अच्छा, अब हम करते क्या? PV equals to nRT. 5.1 times 10 raised to 5. Moles are the same. 8.31. 782 times V. Okay, so V is, anybody got the answer?
Sir, 1.8 times 10 power minus 3.
1.8. Okay. Acha, now to do the next part, it is pretty easy because it is from X to Y. X to Y. X to Y. हम
Sir,
ले
pressure same.
So volume same रहेगा ना?
Volume is same
नहीं,
रहेगा.
sorry,
भैया,
pressure. Oh, sorry, pressure.
Pressure X to Y same है, but we can't do that. अच्छा, अगर हम X to Y pressure same ले लें, तो ये तो बात सही है कि pressure X to Y same है. और वॉल्यूम हम इससे निकाल लेते हैं. क्या ख्याल है? We can do that, right? PV is equal to nRT. दोबारा करना पड़ेगा. This time 1.5 times V, 0.14, 8.31, and 230. What was the answer? Very annoying question.
So मेरे तो same ही आ रहा था 1.8.
1.8 hours. Okay, fine. So that's fine. अच्छा, अब वैसे ना, हाँ, that's fine. It's perfectly okay. So ये not a bad question at all. Very nice question actually. The first law of thermodynamic system. Reference, what is meant by change in internal energy? Q is the heat supplied to gas or system. And W is the work done on system. Explain how the first law applies to Z to X. What is Z to X? Z to X. Okay. अब Z में क्या हो रहा है? Not only the volume is increasing, but the pressure is also reducing. Right. So how does it apply? So if the volume increases, volume increase means work done by the system, right? This means that if that happens, then two things will happen. The internal energy decreases because it is internal energy is Q plus W. If this is minus, then that. Hence, temperature decreases because internal energy is dependent on temperature. Like that. Okay. I hope you guys understand this. Now, a small wooden block. Name two forces acting on the block when it's stationary. Weight down. ये तो O levels का सवाल है. Sorry, A levels का. Yes. And up thrust. Okay. Then Steven explained the direction of resultant force acting on the wooden block. Block is now displaced downwards. So resultant force will be upwards. The reason is that the weight will remain the same, but the upthrust will be greater. As upthrust is greater, weight same. Okay. Then going to this question. Explain why the oscillation of the block are simple harmonic motion. The reason is that why it is simple harmonic motion. That's what it's asking me. Okay, well, it is F equals to minus Ag rho X. I could also write it as MA equals minus Ag rho X. And A will be minus Ag rho over Mx. So I can say that in this one, acceleration is directly proportional to magnitude, magnitude of acceleration is directly proportional to magnitude of displacement. And negative shows they are acting in opposite direction. So that is very, very important. Now they have given you this, show that the angular frequency. So we have already done it, by the way, like I did it in top, like A was equal to minus rho G over M. And this portion is equal to omega square. So omega square will be equal to A rho G over M. And then you can take under root. So root. Right? Is it clear? Now, ये बसाम तो कहता बड़ा मुश्किल भी कोई तो कुछ भी मुश्किल. Okay. Explain why. आगे मुश्किल है. Okay. Explain why the maximum negative displacement of the block is not equal to maximum positive displacement. Interesting. अच्छा इसकी बहुत से रीजन हो सकती हैं. वैसे आप कह सकते हैं कि पानी के अंदर है ना, तो आप कह सकते हैं damping due to drag force. Drag force is the resistance, of against movement. उसके बाद कहता है mass ये determine this energy oscillation for the first half. What? For the first half. What is this? Okay, we can do this. Not big deal. First of all, the thing is, हमारा formula ऊपर वाला, I don't think so it's used anywhere except for A rho G M, but that's not given. Only this is given. So we can actually find the gradient of this line. So what to do? First half, मेरा ख्याल है कि could be anything really. ले लेते हैं यहाँ से यहाँ तक. This is greater displacement. Greater displacement means this should be the first half. So this, my friends, is 2.1, 2.2, 2.3. And this is minus. So first omega for the gradient. Sorry. Gradient would be equal to 2.3 divided by minus 0.02. So this is minus 115, right? And this should be equal to omega square, I think so. But minus sign doesn't really matter because हमने तो वो निकाला omega square निकाला. Fine. So we got this, and what else do we need? So energy का formula is determine the change and decrease in energy of the oscillation first half. Decrease. Okay. So energy is equal to half m omega square x naught. So we have to get 1 and half m omega square x naught 2. Okay. Acha, x naught square and square. Okay, that's fine. अब हमारा सही हो गया. Now we can subtract these two. So we can take half m omega square common. X naught 1 square minus x naught 2 square. Sorry. Yeah, jagah change in energy. Mass is half times 0.57. Omega square
Sir,
is 115. Yes, Lisa.
sir, how do you know that's the first half? Can you take it negative side?
Lisa, first half means that you have, I mean, of course, when you press it down, in the next half it will lose some displacement, right? So first half is reached 0.02. Next half it is reaching less than that. So that should be the first half. Do you understand the logic?
Yeah.
Okay. Now, so omega square is 115, and what else do we have? The first half is 0.023 minus square, sorry, and the next half we have to read off this. And according to this, it should be 1516. Okay, 0.016 whole square. So what was the answer?
4.7 times 10 is over negative 3.
4.7 times. Lisa, you didn't do this paper, I'm sure.
No, I did, but like half.
Yes, so not done. Okay, so state what is represented by electric field line. It is always the direction of force acting on a test positive charge. Writing positive charge is necessary. Now, you have one positive, one negative charge. And it says determine the distance p where two charges where electric potential is 0. Fine. So it's pretty simple. Potential is kq upon r, right? Ab isme na we have to do something like let's suppose that this is the null point. I mean not the null point. This is where the electric potential is 0. So let's call this r. So at point R, let's call this R, and then this distance will be, well, इधर नहीं 0 होगा, थोड़ा इधर होगा R. I'm sure, because this is bigger now. If we call this R, then this will be 0.120 minus R. Okay, so let's keep it like this. Acha, so the first potential due to P would be K. 4. Nano is -9, and R is R, right? And well, interesting, right? And minus, like V, आप कह लें Q is going to be K times minus 7.2 times 10 raised to minus 9, and this will be 0.120 times R. Sorry, minus R. Acha, up potential, you add it says the potential Vp plus Vq should be actually equal to 0. So we're going to add it. So, okay. Divided by 0.12 minus R equals to 0. Acha. Then you take it there. So it will be K and K will just cancel out. Acha. So it will be 4.0. This and this also cancel out. Now I think it's pretty simple, huh? 4. This is not fair. So who got it? Anybody can tell me after this?
So I think it's 0. No, I didn't get it. Sorry.
Okay, you didn't get it. So nobody in this class. That is not good. 7.2 minus 4.0. 3.2. एक तरफ आ जाएगा, sorry, 3.2 R, और दूसरी तरफ आ जाएगा 4 into 0.12, 0.48. 0.48 divided by 3.2, 0.15.
Sir, minus R, minus 4R.
Huh?
So हमने multiply करा ना 4 times 0.12.
हाँ, मैंने
4
गलत कर.
times minus RD.
You're right. 4 into 0.12, 0.48 minus 4R. अब सही. So वो add हो जाएगा मान लो 7.2 plus 4, 11.2. कितना आ रहा है?
0.040.
0.0443. Okay, very good. Now state and explain without calculation whether the electric field strength is 0 at the same point with electric. No, it's not 0. The reason behind that is that the direction of field is same. The direction of field between positive, like positive and negative, is same. So electric field strength is not 0. It can never be. Okay. Then here it says electron is positioned at equidistance from this. Draw an arrow to represent the direction of resultant force acting on the electron. Acha, up from, you need to understand Q was the negative charge, so it would definitely repel it. And P will attract it. But the thing is that these two will have different sizes. The reason for the size is that they have like the charge is different, right? This means the resultant will be somewhere here, like this. I think I need somewhere here. मतलब जैसे भी like this. Is it clear, everybody? You have to be very, very careful in this. Another very good question. This is good. Okay. Now, the variation with potential difference we have charged one of the plates capacitor is shown. The resistance of R is 2.5 and resistance of S is 220. The switch can either position. Okay. All right. The switch in position X, so the capacitor is charged, calculate the energy stored in the capacitor. Fine. So you have a power supply of 8. Now the problem is in this question that they have also given the variation. Energy stored OV E is equal to half QV. So half times 12. Sorry. No, wait. What is this? Capacitor is connected to 8 watts supply 2 resistors. The resistance is this and the resistance is this. When it is connected in this configuration, it won't get the whole voltage, right? Or would it? But if it was connected 8, like it says, if it's fully charged, okay, let's try. So we got 8, that's 1.2. So half times Q times V. 8 and 1.2 times 10 raised to minus 4. So the answer is
4.8 times 10 raised to minus 4.